I want to do a space shot, a rocket that goes over 100 kilometers and then comes back. I do not currently have the capability to build this vehicle, so we need to build a bunch of rockets between now and whenever that space shot happens to sort of build me to that point. Some of you may have seen that about a year ago, Joe Barnard and Mark Rober did a video about the world's highest egg drop. If not, I will link Mark's video in the description below. But I want to beat their record. I have not built the vehicle for this yet, and it won't fly until mid or late 2025. But the upper stage will not have fins, and it instead will use TVC, or thrust vector control, to stay stable and perform some very crazy maneuvers, definitely not associated with a very famous and powerful vehicle that the FAA hates. But anyway, let's take a look at the CAD for the vehicle. Okay guys, I have the vehicle modeled up in Onshape here, and we're just gonna take a quick look at the vehicle here. So the vehicle is about a foot and a half tall and is 54 millimeters in diameter, or 2 inches. And most of it is 3D printed in PLA. What you're seeing right now is, everything that you're seeing right now is 3D printed. So the nose cone is hollow. It is 0.1 inches in thickness. And then the avionics bay and booster section are about 1 millimeter in thickness, and then down here we have the launch pad adapter, which allows the launch clamps to grip the vehicle. So if I get rid of, let's see, the booster section, down here we can see this. As you can see, if I turn it back on, I have everything on the vehicle turned on right now. And as you can see, there are no fins. So this thing shouldn't be able to fly. But this is what allows it to fly. This is the TVC mount, or thrust vector control mount. So it works by moving the engine to change the vector, or the direction of the thrust, to maintain control on the vehicle. And it's got 3 layers, or 4. The innermost layer is the mount of the engine. There's one right here, which is the yaw layer, and then this is the pitch, or the pitch. This is the pitch layer, and then this is the mount. And then down here, we got the launch pad adapter, so I'm going to turn that off. And then I'll turn the booster section back on. And then if we come up here to the avionics bay, and I turn the avionics bay off, you can see that we got a few things here. So this is the computer sled, so it holds our flight computer. So this is the flight computer, and then back here we'll have a LiPo, or lithium polymer battery. And then up here we have a roll wheel, which, if I turn that off, I guess it's technically called it is a reaction wheel. This is the motor that drives it. We have the mount for it right there. I'll turn it back on. And up here we have nothing inside the nose cone. Actually, I don't have it modeled here, but we'll probably have the telemetry antenna in there. Okay guys, so this video wasn't super in-depth, but do not worry, we will be doing a video for everything to do with TVC1, including recovery testing, full stack testing, the airframe of the vehicle, the TVC gimbal, the launch pad, launch 1 prep, and avionics, and so much more. But before we wrap it up, I would like to thank Everyday Astronaut for his music. I will link his channel and his music in the description down below. You can also find a link to my Patreon page, also down in the description. You can find a link to a poll about some model rockets. It'll explain more on the poll, but definitely go check that out. And also, YouTube apparently doesn't trust me with links, so until I figure that out, you will have to copy and paste the links into the search bar. I am really sorry about that inconvenience, but thanks for watching as always, and my name is Liam P, and I will see you next time.